Mass spectrometry is a very popular analytical technique. However, when it comes to compound identification, then the real problem starts. To investigate what kind of compound we are dealing with may be a tricky thing, but with the right tools it is not so difficult. One way around this is the library search method, that is taking advantage of the fact that each compound has a characteristic spectrum that differentiates it from others. Like forensic scientists match fingerprints from a crime scene against a database of fingerprint records, mass spectrometrists compare spectra of unknown compounds with spectra of compounds stored in the mass spectral database. In our case, we will use mzCloud, a mass spectral database that is freely accessible on the internet. On this website, you can search an unknown spectrum either by clicking on the spectrum search link, or you can search from the database, which I will show you now. Here you can see records of various compounds and their corresponding spectra. To search a spectrum, you can click the Search tab and then the spectrum item. First, we need to upload the spectrum we want to search. We can do it in two ways, either by opening the spectrum from a file of common spectra formats or copying the spectrum in Excel and pasting it here. If you do not have a spectrum ready and just want to try the search, you can click on Insert Sample Spectrum. Now I will show you how to search spectrum from Excel that I am really curious from which compound it is coming from. It's simple. Just copy a list of mz values and intensities from Excel and switch to mzCloud and click Paste. As the search algorithms need to know the mass accuracy, we need to enter the appropriate value. But if you are not sure about this number, we can keep the preset value. mzCloud automatically determines the noise level, shown as a red line in the spectrum. That can be modified, but as this automation works really well, we will keep the suggested value. There are a couple of other useful parameters that you can experiment with, but as of now, we will keep them as they are. If you are all set, click OK. The results of the found spectra are shown in this column, being sorted from the most similar spectrum to the least similar. Since the first hit exhibits a very high match factor, shown here, and also the visual difference between the library and Curie spectrum is minimal, we can assume that we found the right compound. Because the hit list contains other spectra with a high match factor, I am not absolutely sure. To overcome this uncertainty, we can change the search parameters by clicking Edit Search Options here. One parameter that can significantly reduce false positive results is the precursor value that will make the search more specific. Now I will enter the correct value. Click OK to see the results. Now we see we ended up with a single compound that turned out to be capsaicin, a known component of the chili pepper. This is the end of our investigation, and as you have seen, it is pretty easy to search your spectra in this very useful database anytime you need to find the identity of a compound. Just one more thing. All you need is a modern mass spectrometer that will set you back a few $100,000. Thanks for watching.